Hello, and welcome to another LeetCode video tutorial. In this video, we will go over the topological sorting algorithm. What do we mean by topological sorting? Let's look at this example first. Say we have four classes, A, B, C, and D. Assume that if we want to take course B, we'll have to finish A and C first. If we're going to take course C, then we have to finish A first. If we want to take course D, we'll have to finish C and B first. So that's the meaning of the arrows on the graph. It shows the prerequisites for each class. In the graph, we can see that A doesn't have a prerequisite, so we can take this class first. Let's put A first. B has two prerequisites, A and C, which are these two classes. For C, its prerequisite is A, and for D, its prerequisites are B and C. The problem becomes, in what order do we have to finish the four classes? We can take A first because it doesn't have any prerequisites. After taking A, then we'll take C because C has a prerequisite of A, so we can take C after taking A. When we're done with A and C, we can take B, and after taking A, C, and B, we can take D. In this problem, A, C, B, D is in a topological order. So here, by topological sorting, we will get A, C, B, D. It represents the order that we have to follow to get something done, and ultimately finish everything by following this order. Now let's talk about the algorithm for topological sorting. It has two very important concepts, that is, in degree and out degree. The in degree is the number of arrows pointing towards it. For C, its in degree is 1. The out degree is opposite. It's the number of arrows pointing out from a node. For C, there are 2, so its out degree is 2. Let's get started with the demonstration. First, we need to calculate the in degrees for A, B, C, and D. For A, its in degree is 0 because it doesn't have any prerequisites. When we see a node with a 0 in degree, we will add the node into its data structure, which is the queue here. This queue stores all the nodes with in degree 0. Now, let's add A because we found it has an in degree of 0, which means we can take A first. And then for B, its in degree is 2. For C, its in degree is 1, and for D, its in degree is also 2. When we're done calculating the in degree, we can get the first class that we can take from this queue. Here, we take out A, and we're going to have to erase it from the queue. We will mark it to show that we are done with A. Then, for the remaining courses, we will search through them again to find the courses with A as a prerequisite and subtract 1 from their in degree because when we have taken course A, this layer of dependency is no longer there. Since I'm done with A, they are now available in this graph. After subtracting 1 from in degree of node C, we will get 0. At this point, we see that C has an in degree of 0, so we add it into the queue. For B here, its in degree will also decrease by 1 because it has A as a prerequisite, so its in degree becomes 1. For D, its prerequisites are B and C, so we don't do anything for it. Now, let's take out the first element from the queue, which is C. We'll remove it from the queue. This means we just took C. We'll mark C as completed, and then we do the same thing again for the two remaining courses. We will subtract 1 from the in degree for all courses with C as a prerequisite. For D, since C is a prerequisite, we get 1 after subtracting 1. Then for B, it also has C as a prerequisite, so let's subtract 1 from it and make it 0. This means we can take B because its in degree is 0, so it doesn't have any prerequisites anymore. We'll add B to our queue. At this point in the graph, we can see that we're done with A and C, and we can take B next. Now, we'll take the first element out of the queue and delete it to show that we have taken it. For the remaining courses, we take all the courses with B as a prerequisite and then subtract 1 from its in degree. So what we're going to do is subtract 1 again from in degree of node D, which makes it 0. Now we can take D. We'll add it to the queue and take it out and delete it to mark it as completed. Now we have taken all 4 classes. We can check the queue and realize that it's empty. This means we've taken all the classes possible in the graph. We can see that the order we got was A, C, B, D, which is the order we have here. This is the algorithm for topological sorting. Now, instead of having class A as a prerequisite for class B, what if we have class B as a prerequisite for class A? Now we realize that A, C, B forms a cycle. If I want to take A, I must take B first. If I want to take B, I must take C first. And if I want to take C, I must take A first. So which class would we take first? This shows us that for a cyclic graph, there is no topological ordering because we'll never find a class to start with. In other words, for a cyclic graph, topological sort does not work. There's another way we can prove it. We can use the algorithm of topological sorting to prove it. First of all, let's look at A. Its in degree is 1. The in degree for C is 1, and the in degree for B is also 1. The in degree for D is 2. Using the topological sorting algorithm, we need to find a class with in degree 0 to start with. But here, you see, we can't even find a class with in degree 0. So at this point, the topological sort doesn't work because we can't find a topological order. So for a graph containing a cycle, it has no topological relationship. You can't do a topological sort at all. Be sure to pay attention to this. Thanks for watching. Hello, and welcome to this LeetCode video tutorial. In this video, I will explain how to solve LeetCode 210, Course 2, using topological sorting. We are given a number n, which represents the number of courses. We are also given a 2D array showing the dependencies between classes. Let's use the first example. We have n equals 4, so we have 4 classes, 0, 1, 2, and 3, from 0 to n minus 1. We are also given this 2D array showing the dependencies between the 4 classes. For the first class, if you want to take class 0, then you have to take class 1. And also, if you want to take class 0, then you have to take class 2 first, and so on. Now, let's put classes 0, 1, 2, and 3 onto this graph, and then we'll draw out their dependency. Here, class 1 points to 0. This means I must complete class 1 before taking class 0. Similarly, 2 is pointed to 0. This means I must complete class 2 before taking class 0. And this edge means I must take class 3 before taking class 1. And this edge means I must take class 3 before taking class 2. For the topological sort, the main thing we need to look at is the in degree of a node, which is the number of arrows pointing towards that node. On this graph, the in degree of 0 is 2, the in degree of 1 is 1, the in degree of 2 is 1 because of this edge, and since no edge is pointing to 3, the in degree is 0. We also need a queue, as shown here, to store all the nodes with an in degree of 0. Since we just found that the in degree of 3 is 0, we'll put 3 in our queue. Now we need to take the first element from the queue, which will be the next class we can take. At the same time, we'll remove it from the queue. This means I'm done with class 3. We will mark it, showing we are done with 3. This means we are also done taking the prerequisite for these two classes. Next, we have to look at the classes not taken that have a prerequisite of class 3, and reduce their in degree by 1. Here, node 2's in degree will equal 0. Once we find an in degree of 0, we'll add it into the queue. We will decrease the in degree of node 3 by 1 as well, and we get 0. We found another class with in degree of 0, so we'll add it to the queue. For node 0, it's not a direct dependent of node 3, so we don't decrease its in degree. We'll keep 2. Let's get the next element from the queue. For 1 and 2, it doesn't matter the order. We take them because they both have an in degree of 0, so any order will do since they're not dependent on each other. Taking class 1, then 2, or the other way. Either way is fine. Here, we take the first element of the queue, which is class 2. Then we'll remove 2 from the queue. This means we're done taking class 2. Again, we have to look at the remaining classes that are dependent on 2 and decrease their in degree by 1. Here, node 0 is a dependent of node 2, so we subtract 1, and then we take the next element of the queue, which is class 1, so we remove it from the queue, meaning we are done taking class 1. Now we need to decrease the in degree by 1 for the remaining classes dependent on class 1. So 1 minus 1 we get 0. Since the in degree for 0 is 0, we will add 0 into our queue. Finally, we will take the next element from the queue and remove it from the queue, meaning we are done taking class 0. Just like this, we have solved this problem using topological sorting. The process of this algorithm is very intuitive. We just have to see the dependencies in the problem to solve it using topological sorting. Thanks for watching.